This problem is asking to determine the more likely of two compositions at different temperatures. So the first part is asking if composition A or composition B is more likely at 100 kPa and 300 Kelvin. And then the second part is asking which composition is more likely at 3000 Kelvin. So we're going to do system states and the general mixture and IgE model. And we're going to do our first composition, composition A, which is 1 kilomole of pure CO2. So just add that. All right. And we have P1 equals 100 kPa. T1 equals 300 Kelvin. Calculate, and we get a Gibbs function of about negative 10,400. All right, and then state 2 is still 100 kPa and 3,000 Kelvin. All right, and for we need to change that to reactants because we're still focused on the CO2. And so we get negative 28,000 for that one. All right, and we'll just note those down, and then we'll try the second mixture, composition B. So I initialize the mixture, changing it back to kilomoles, and this one is this formula right here, 0.95 CO2 plus 0.05 CO plus 0.050. So we're going to enter that. So 0.95 CO2, 0.05 CO, and 0.50. All right, and we'll add those. Go back to the state panel and we'll recalculate. So for composition B at 300 Kelvin, we get negative 9,867 for the Gibbs function, whereas with composition A, we got about negative 10,400. So for the temperature of 300 Kelvin, composition A is more likely because it was lower. The Gibbs function was lower. Right now for state 2, we recalculate, and we get a Gibbs function of negative 28,389 kilojoules per kilogram. Before it was negative 28,255 with composition A. So this is lower, so composition B is more likely at 3000 Kelvin.